Okay, hey all, welcome to our next webinar. So as I mentioned before starting recording, I would like to make it as much interactive as possible. So when I will be explaining you the concepts, then feel free to interrupt me. You can ask questions or put your comments via voice, or you can place them on chat window. Don't be shy. If something will be planned to show you later on, then I will try to be assertive and tell you that I will be discussing that a bit later. So I have a specific plan on how to proceed, but still, let's make it fun. So before I go to the code, because we will see a lot of code, let me start with a brief introduction to the topics and to the issues that we might be facing while working on the event sourcing, but also event-driven system. The focus will be on event sourcing, but definitely similar patterns can be used in general for EDA. So let's say that we have this boring domain, but I think that this domain is actually pretty good on discussing those topics. So shopping carts. And let us focus on the small part of the process that we might have in the shopping cart management. So the final confirmation. So once we added some product to our shopping cart, then before we make the final ordering process, then we need to confirm the shopping cart, and then the other parts of the process needs to start. So typically we are sending some command, which is like intention of what we would like to be doing. And then we need to run the business logic. So we need to check some invariants, like for example, is shopping cart open? Do we have any products? And we are making those decisions based on state. And here there is no difference from the classical state-based approach to the event sourcing. If we are using event sourcing, then we are getting one more component that is a bit different than regular. Not so different, as event stores are also databases, but the critical part that we are doing here before we even run the business logic is that we need to read the events from our event store. And this is the really significant difference between the streaming and event sourcing, because we are not subscribing to events, we are reading them. But so actually we are reading a stream of events, and stream of events contain all the events and all the facts that were registered for this shopping cart. So it will probably have events like shopping cart open, product item added to shopping cart, maybe again the same event, and maybe removed. And based on those events, we are building this specific state. So the state that we will be making our decision. And in the end, once we run the business logic, and let's say that we had the happy path, so our business logic succeeded, then as a result, we need to store those events. And so far, so good. And the next phase that can happen after we store those events is, of course, that we can do something with those events. So what we can do with those events is that, for example, we can run the subscribe to the notifications, and based on those notifications, run so-called projection logic, so transform those events into some read models. And all of that, we are still speaking about staying inside the specific module. So those read models logically, keeping the logical boundaries, are still inside of our module scope. So I'm not talking about publishing yet to some messaging system. Just we are storing that into our event stores. Event stores are giving us possibility to subscribe to the notifications, and based on those notifications, we can build read models, and then our user can read them, and it can query them to get the data, right? So this is what our user is doing. Okay, and the other scenario that we might have with our events is that we can subscribe to those events and do one more step. So use those events to integrate and to forward them to some messaging system. It can be Kafka, it can be SQS, it can be Google PubSub, RabbitMQ, whatever we prefer. But we can subscribe to those events, and based on those events, we can trigger some other business logic in some other module. So for example, in shipments. So we can push those messages to our to some messaging queue and then subscribe, run some business logic, or we can also run a similar thing as we have in our module. So build the local representation of our process inside this other module. So yeah, so we can do it like that. And all of those scenarios require a bit more thinking and a bit more scenarios, because there are some patterns when our model is changing that we can handle inside of our module, and usually handling model changes inside the modules are easier than doing them in terms of integrating that with other modules. So we will start with the simplest stuff. So this specific part. So we will be starting with reading events, appending events, and then we will discuss how to move forward and how to apply patterns to some other specific parts of our systems and other integrations. So the starting point will be this one. So running the business logic. So how to handle if our model changes and we need to read events, and we might have multiple versions of the specific events, and then how to handle event appends. And then we will see maybe those patterns can be also reused in other places. Any questions so far or to this diagram? I take the silence as a no, but feel free to interrupt me. Thanks, Zach, for the feedback. So let's have a look on how we can handle this versioning. So let's say that we have some current existing schema. So our schema is really, and events definition is really basic. So we have the shopping cart open, product item added, removed, confirmed, and so on and so forth. So I'm sure that you are buying even too much stuff on the internet, so you know this process. But let's say that we have the following event, the first event in the shopping cart journey. So shopping cart opened contains information about the shopping cart ID and the client, because we need to know precisely for which client, so customer, we are opening our shopping cart. And let's have a look how we can start with the really simple scenarios. So the most obvious scenario, is the font size okay, or should I make it a bit bigger? Just double checking. So thanks, Martin. Thanks, Bartek. Okay. Luckily, we are not on the conference because then that would be too small. But sorry for the side note. So the most obvious example of the scenario that and the easiest scenario to handle is that when we are adding a new not required property. And the new not required property is, for example, that let's say that in the initial event, we just had those two properties. And then we realized that, gosh, we are so dumb. We forgot to put the date time with the information when we actually open the shopping cart. And those information can be any type of additional data. And in general, the best practice, if we are handling the schema migration and schema evolution, is to include our changes in a non-breaking manner. So if we don't know which data we can use as a default, then we should always try to be explicit and say that this information could have been not provided. And if we are using the default scenarios for handling JSON schema, then most of the serializers are, in that case, will assign a null value in case of C# or Java, or undefined value for JavaScript. Of course, we can turn on the strict mode and fail if we have some additional property or that we didn't know. But if we provide this field as a nullable, then it means that it will be both backward and forward compatible. And we will discuss later what does that actually mean that it's forward compatible. And also my recommendation is never for events schema definition, assume that we have a strict and a strong schema. I think that weak schema is actually the wrong name, because weak schema is really powerful because it allows to easier evolve. If we are doing the changes and handling our engineering hygiene, because I think that not doing breaking changes is part of the proper engineering culture and in general engineering hygiene. So here, this is an example that we had the original event, so the one that didn't have this initialized add, and we are serializing this event and trying to deserialize it into the new definition. I'm using here the system text JSON, which is the .NET serializer. And then, as we can see, we are expecting that this should be null. I could even try to run it, we'll see, just to prove you, but I'm not sure. We are doing live webinar, so that might not be the smartest move, but we'll see. And in the other way around, we would like those our events with the new schema, so the one with the opened add, we would like to make this also backward compatible. So if we are reading events and we are expecting to have the old schema, then it also shouldn't fail. And in this case, as you can see, this shopping cart doesn't even have this property. So if we are using the weak schema, so if we are not using the strict mode, then we are fine to deserialize it in both ways. So that's the easiest example. And the backward compatibility is especially important here if we are reading events, because I mean the forward compatibility, because we can get events with the old schema but we would like to use in our code events with the new schema, because maybe we don't want to maintain the multiple version of the same stuff. And maintaining the forward compatibility is especially important for those integrations, because if we are publishing event with the new schema and our shipment modules doesn't know that yet that this new schema even exists, then it's really important to publish our event with the definition that can be backward compatible. Because let's say that we are publishing here the version 2, but shipments module didn't yet update their code base to have even the knowledge about the new version. Then if we publish that event with the version 2 that is still compatible with version 1, then this module doesn't have the implicit coupling. Because if we were publishing schema definition v2 that is not backward compatible with the v1, then we would need to deploy both shopping carts and shipments at the same time, which can be, of course, possible if we are doing modular monolith. But if we having the microservices world, then typically that's not the smartest idea. And even if we are doing monolith, then typically we would like to use some load balancing, or we still might have some multiple instances of our system, because we would like to make it resilient. So if one copy fails, then the other wakes up, then there might be this blind spot where we have both versions. So that's why it's extremely important to not do breaking changes. So if you want to take at least one lesson from this webinar, not making breaking changes, because then life becomes much easier. Okay, but let's have a look on how we could proceed with potentially breaking changes. So the simplest example of that is that we have the new required property. And the new required property might mean that, let's say that initially when we were opening the shopping cart, then our status was always opened, because like Captain Obvious, if the event is named shopping cart open, then typically the status of our shopping cart is open. But let's say that we found out that there are some users that are trying to cheat our process, and there are some people that either are spamming our system or trying to find some leaks and doing some breaches. And we would like to, for some specific types of behavior, sure, I can do it. Is it better, Pavel? Yeah, so for some specific type of behavior, we would like to run some fraud detection mechanism. And then for that part, we don't want to put this shopping cart open in the open state, but maybe we would like to put it into some pending, or maybe explicitly say that this is just for under fraud detection. So in that case, we can assume that for those payloads that didn't have this status defined, so if we got the JSON without the status property, then in this case, because we know why we made that change, then we can assign a default value for this particular case. So if it doesn't have, then it means that it was stored under the old business logic, and that means that all those statuses will be shopping cart open. And in C# and Java, I will show you later on that in Java it really looks almost the same. The serializers are smart enough to do it, to assign this default property. In TypeScript, it's not that easy, but we will get to that later. But still, you can, and you need to, if you want to make this new required property really required and not nullable, then you really need to provide a new specific value. And if we have a look, and if we think about the migrations that we are doing in the traditional systems, so for example, relational one, then if we are, then if we want to add new column to the database, then the safest option is to do as we did here. So make this new column nullable, right? But if we want to make this newly created column not nullable, then we need to provide the default value. And we can do it here. So for example, under the serialization. And then we are adding something that is required, but with the default value. And now the tricky part is that we are actually not updating events, because our payload will still look like, it will look something like that. Let's say that this is unique ID. So our payload will still look like that. And some may say that, well, but we didn't do any migration and we will always need to do this on the flight. And that's correct. That's some additional mechanism, and we will see some more advanced transformation. But if we think about what are events, then events are facts. They already happened. And there is a big value in knowing precisely how we recorded those events. Because let's say that we tried to do migration, and now adding this status and set it to open, right? For those old values. And we ran the migration, but then we broke the migration, or we accidentally put it to closed because we wrote the wrong migration script, or actually we broken the initial data. And now, from the auditability perspective, we are not sure what were the precisely recorded events. So having those events as they were is really powerful, because then we can interpret them in a multiple ways. And doing this default value is some sort of basic interpretation that happens automatically during the deserialization. So really, I think that it might look at the beginning counterintuitive that we need to always do it, but on the other hand, it's really, really close to any other type of migration that we would be doing. And in this case, if we are doing, then those are the similar tests. So we are serializing with the old schema, deserializing, and we see that it should be open. And here it's also backward compatible, because we are just adding new property. And if it's new property, then typically those deserialization will just ignore this property and not assign it. And what might be surprising for some of you, but introducing new property is also the rename to the property is also the breaking change. We as a developers really love to do some renames and refactorings. So for example, previously we had the shopping cart ID, but now we've said that, okay, I have this shopping prefix, then I don't want to have this. Previously I had it like that. So I don't want to have this prefix because it's redundant, then I will just remove it. And that is already a breaking change. Such change is already um, making you enable to deserialize the old value. Probably if you would do it like that, then if you try to again deserialize it, then it would assign the default value of the unique identifier. So it would silently cause some issues. So, but most of the serializers can also handle that. So if we want to rename our property and we would like to keep it like in code in a different way, but in the serialization in a different way, then we can use, for example, some attributes or annotations on our properties, and then say that if this property is serialized, then it will be serialized to shopping cart ID. And if we are deserializing, then try to get it from this shopping cart ID. And again, let me get this JSON. So the tricky part is that if we serialize it in this way, so we are saying that you need to use the shopping cart ID, then it will not serialize the new events with using the cart ID, but using the old one. So if we had typo, because for example, we had instead of shopping cart ID, then we had shopping cart ID, then unfortunately, that means that we still need to keep this shopping cart ID, because then it's potentially the wrong way. So the alternative to that is to add additional property. So have store it like that. So store it like cart ID, and also have the old version of that. So once we have those two properties, this is the rename one. This one we might name as obsolete. And then we would be keeping those value together. So we could use it like that. Some serializer allow us to do it like this way. But I'm not sure if system.text.json is smart enough. So it will be like that. So either use it from the cart ID or use from the shopping cart ID. So then we will be storing in the new format and in the old format. And I will tell you later on how you can get rid of those potentially old formats that you don't want to keep forever. But still, the simplest option, and I think that potentially the best one, is to keep this old naming as it was, and we can live with this old schema potentially. So just to prove you that in Java it looks almost the same, I never remember what is how to zoom, Pavel, in IntelliJ, so sorry for that. It will be a bit smaller. So yeah, so this is the new not required property. So we are again adding it. In Java, everything can be nullable, what is class. So this means that this is nullable in Java. And let me show you more. So new required property, we need to do it, we can do it in a bit different way because we don't have those default values in Java, but we can have the constructor for the record, and we can say that if I got null, then assign the default value. So it's almost the same. And for renamed using Jackson serializer, it's the same. So we are using JSON property in this case. And for TypeScript, it's almost the same. So new not required, we can define as nullable. So that means that it can be undefined. The new required property is not so trivial because if we have TypeScript, then in type definition, we cannot provide the default value, but we can do it like that. So we can stringify the new schema and do some additional mapping. So JSON parse give us possibility to provide the additional mapping, and we can do, while parsing that, we can do some additional mapping. So if the status was null, if it was undefined, then use the shopping cart open. So we still can provide some specific set of mappings. And for rename property, we would need to do it also a bit manually. So for parse, we would need to use the map as we had. And we are storing both old schema, so shopping cart ID, and the cart ID to keep it backward and forward compatible. And the other way around, we would also need to store it manually. So at least that part in TypeScript requires much more manual intervention. But I'm showing that to you to show that not all environments are super smart, and maybe that's cool because too much magic is also not helping. So do you have any questions around this simple transformation and simple mappings? Because really using non-breaking changes policy and those simple mappings can be good enough for really a lot of scenarios. I would say majority of simple scenarios, and then we will go to a bit more advanced version when we want to do a bit more magic. Okay, I don't see questions, so I hope that this means that it's quite clear. So let's have a look on the different strategy. So let's say that we had our shopping cart open and previously it had only client ID. So just to remind you, the old event had just the client ID. And for some reason, we decided that we want to add additional information, so the client name. I don't want to discuss whether this is a good or bad practice. In general, of course, we should try to avoid put too much into events, but sometimes it's fine to capture also additional data, potentially redundant. But for example, it can be useful for the projections. It might make projection handling easier because you won't need to read additional data. Let's say that this is a trade-off that we decided to do. And now we are saying that because we are we want to be object oriented, then we decided that instead of just keeping it as like that, like client ID, and having additional property with the client name, then instead of having it like that, we decided that, well, If it's client, then we would like to group it. And that type of change is already a breaking change because we cannot serialize it. We cannot deserialize event in old schema. If we serialize it as it is, then it will be again not working correctly because it won't be neither backward nor forward compatible. So how to deal with that? And the potential example of how to deal with that, with the transformation, when those simple techniques that I showed you before won't work, is to use so-called upcasting. So we are taking the old event and we are transforming it into the new schema. So this event could come from the initial deserialization. If we want to keep in our code base also the old event type, then that's okay-ish solution. The only downside potentially is that we have more allocation because first we need to deserialize it to the old event and then transform it into the new one. The benefit of that is that we have this strong typing and that we can do those transformation using like our favorite language. So like that. But if we want to be super performant, then we can take write the upcasting logic in a way that we are taking the old event JSON, just the JSON we got, or byte array, because those techniques that I'm showing using JSON, but also other serializers like protobuf and so on and so forth give you a similar capabilities. So then most of the advanced serializer give you the option to do the manual and raw parsing. And benefit of using stuff like this JSON document parse, or if we are using Java, then in Java it would be like that. So the serializer JSON node, then those types give you possibility that here we are not yet parsing information. We are only parsing when we are calling, for example, get property. And I'm calling that a caveman deserialization. Personally, if I'm using C# or Java, then I would prefer to benefit from using this environment. But definitely this can be more performant, reduce allocation, and it can give us better flexibility because we can do whatever we want with this JSON. So even if we have some weird or potentially broken JSON, then this is the possibility to somehow fix it or do any type of manipulation that we want. So for example, it might be in the wrong format. It might be located in many different properties. Sometimes that happens. And doing this scenario also helps. And that, so as I said, we can just take the old event, which may come from the serialization, or we might have the raw JSON and call the upcast logic and transform on the flight our processing. So if we go to our Miro board, then this transformation will happen somewhere here. So if we are reading events, then this will be our upcasting. So it will be still part of the infrastructure. We might inject this function. I will show you a few ways how to do it, but this happens in between. So we are reading events in the old schema from our database, so as they are, And then event by event, if we need to do it, then we are calling the downcasting, the upcasting, and then using in our business like the building the current state using just the latest schema potentially. And this also gives us possibility, like for example, to reuse some of the metadata from our event. So let's say that we forgot to put information like who initialized the shopping cart, or maybe this approver if we had the fraud detection, or it might be some timestamp like this missing initialized ad data. And if we have this information in our metadata, because event stores are not only keeping our data, but also stream metadata. So timestamp usually, so when it was added, some position, we can put some custom metadata like this user ID. So if we had that, then we can potentially use that also in the upcasting logic. So we not only have to pass just the event data, but we can use also the potentially the event metadata. And then we can use those, of course, if we have those information in our upcasting processing. And we can also both have the metadata, which is the class, which is strongly typed, or we can just have the raw JSON or raw bytes and parse it and use it in our logic. So any questions to that part? Should I explain something better, or is it clear? Okay, Martin, thanks for feedback. Glad that you're good. If you have any questions, feel free to ask them via voice or on chat. So right now, what we discuss is this upcasting, and those simple techniques that we used, what the serializer is giving us, is also some sort of upcasting, but upcasting that is happening automatically thanks to our serializer capabilities. And the other way is, as I mentioned, because here we are taking events in the old schema. So let's say that this is the V1. Let's do it like that. So we are taking event in V1 and transforming it into potentially like V2 or V3, right? So this is our transformation. So this is what is upcasting. But as I mentioned, we not only want to be forward compatible, so we are getting old schema and be able to deserialize it to the new one, but we also want to make it backward compatible. Even if we are, of course, if we are thinking about the business logic, then if we start even in the old schema, in the new schema, then we of course will be able to get it, because this upcasting will handle that. But not always we are deploying our components, so our business logic and read models, in the same container. Sometimes we are splitting, and write model part is deployed as one version, as one service, and read models are also published as a separate one, because, and that's quite common, because this part can be run asynchronous, like read model processing, and it might require different scaling capabilities than this one. So it would be good if we were publishing and appending events that also our internal module could keep it up. So if they got the events in the new schema, then they could be also using with the old one. And for that part, we will be using downcasting. And downcasting is the other way around of serializing our data. So, for example, if we are storing events in the new schema, then potentially we could downcast it into the old schema. Or maybe if we are downcasting, then maybe we would downcast that to the type that would have both old and the new schema. So downcasting is happening here. So we are taking event that is in the new version, and best if we are downcasting it to the event that is that is both forward and backward compatible. So it's like a union of those two versions, because if we are storing that as an event that is compatible both with the old and new schema, then also our services and external services will be able to catch it up. And I will show you a different technique than those one, like that is quite common in other environments than Java or C#, because Java and C# serializers are, as you saw, enough powerful to plug in, and they can do a lot of magic. Actually, they are not only serializer, but also some sort of mappers. But the other quite common case is that using explicit serialization and deserialization class that is called usually serde, or serialization, deserialization. So let's say that we have our shopping cart event, and this shopping cart event is the event with is a union type. So we are saying that our shopping cart event will be either of those types. If we are using C# or Java, we could define it in a similar way. So write our classes as records and implement the same interface. So it's just grouping all of the event types that we can register for our stream. So all the facts that can be registered. And here we would like to maintain just the latest schema, because then if we are doing this evolve function, so building the state from our events, then we don't want to have here in this evolve function all versions of our processing, like shopping cart v1, v2, v3, v4, v5, and the same for other events. That would be just a lot of noise. And the potential option for that is to, in JavaScript at least, we can define a type that contain information about the all potential payloads we had in past. And in the C# or Java, we could define it in a similar way. So have a separate grouping that contains all the schema that we had. So in this case, we had three types of events definition. The first one that just had shopping cart ID and client ID. The other one that had client grouping. And see here, I'm keeping it both backward compatible and forward compatible, because I'm not only publishing the new version, the new grouped client, but also the old way. So this is like the obsolete, as you see here. So I'm keeping it as an obsolete, but for the compatibility. And I'm giving also this new required property. And let's say that we only had those schema migration only for the shopping cart open. And so how to proceed with that? If we have such a class, which is the shopping cart event serde, then we could have the two methods. One is the serialization, and the other is deserialization. So serialization takes the shopping cart event, so the one that we will be appending in the new schema. So in other words, also like a domain event, and it's returning the type that is representing all potential permutations of payload and versions that we had in past. And having such methods, it might seem that it's a bit redundant and there is a lot of manual stuff needed, but see, like here, we are having a clear type definition, and we, especially in the deserialization, it's really great, because let's say that we introduce the new type, forgot to handle the initial shopping cart opened, and here we will get the compiler warning. Like compiler will say like, hey, you forgot to implement the initial one. And only if I handle all the versions, then I will have the type checks corrected, and compiler will tell me, yes, now it's okay. Or for example, if I forgot to assign the client name for the event where we didn't have this name, then it will also tell me that this is the wrong value. And here I'm also seeing in this deserialization method, I'm clearly seeing all the schema evolution in one place. And I also have the clear mapping and the explicit mapping of what I'm doing. And in JavaScript, that looks quite nice. In C#, it would look a bit different. Let me find it. So in C#, typically, and other places, what I saw is that people are doing that they are using those so-called caveman manipulation, but also more performant. So see, I'm shaping here. If I'm serializing, then I'm building the JSON object manually. So I'm clearly can do whatever I want and shape the JSON structure as I want. Or maybe in the serialization, I could use just the regular serialization if I don't want, or have the fallback. And here in the deserialization, I can do the same. So if I'm getting the specific event type, then I can deserialize it in a form that is the most suitable for me. So in that case, we are getting, with the serialization and deserialization, both upcasting and downcasting, and it's quite easy, or easier, to handle that. However, as I said, you don't need to do those types of manipulation if you're adding new, like if you are adding new property, or maybe if you are changing schema. So for example, if we have something like here, then maybe we could just keep the previous information as it was and mark it as obsolete. And then if we do it like that, then we have event, even if we introduce this client ID, then we still have something that is both backward and forward compatible. So that's my really that's why I'm saying that not introducing breaking changes and taking care about that stuff really makes stuff much more easier, because then maybe we don't even need to use or write those custom upcasters or downcasters, because our schema by definition is both backward and forward compatible. Okay, so getting back to our TypeScript example, in Java it's almost the same like in C#, so I won't be showing that. But if we have this our real event store, then let's have a look on how we could use our serde class in that type of real world usage. So let's say that we have method aggregate stream. An aggregate stream is a way that we are building the state from events. So the first thing that we are doing is that we are creating the default object. It might be created by default constructor or some function that we provide. Whatever we do, we are creating the default state. And then if we are reading events, then for each of those events, we can provide this parse method. And either if we provide this parse method, then we are doing that. So this is like, it can be upcaster, it can be our serde class. And in that case, if we provided that method, then we are trying to parse it. And in other words, we are just using what we got and using the default deserialization mechanism. And then once we had this parsed event, which is already upcasted, then we can use it to evolve, and we are passing to the evolve function. So the function that is building our state, evolving our state based on events, already upcasted event. And then once we went through all the events in the stream, we are getting the new state. So this is the really the general approach that you can use. And in aggregating stream, so see, we are saying that if I have method get shopping cart, then I'm trying to read events from this stream. This is the, I'm passing a default object as this shopping cart. I'm passing the evolve function that you saw before, and I'm passing as parse, I'm passing this deserialize method from the serde. So in this case, I'm just passing and using it while aggregating stream. And in the same way, while appending events to stream, I could use the downcasting. So I can also provide the serialize method. And if I provided this serialize method, then I'm using it and returning the data. And if I did not, then I'm just using the default serialization mechanism. So this is quite flexible. And this is quite powerful mechanism. And this is how, in nutshell, you can do it in your event store. But if you are not using event sourcing, but you are, for example, just using Outbox or passing messages through messaging system like Rabbit or Kafka, then you also, while receiving events, for example, from Kafka, you also need to map them, and potentially you might get those messages from other systems in the multiple schemas. So if we are doing in the messaging system, then here we could also put precisely the same upcasting logic. and it can be either upcasting or downcasting, depending on if we don't know yet the new schema, then probably we would have some sort of downcasting. So we can do the same transformation on the receiving end. So this is like potentially the ACL. Or we might use the same technique and use upcasting on this side. So if we are getting events from event store in the new schema, if we are getting in the events in the new schema from event store, then we could also do the downcasting and publish events with the schema that is compatible for both old one and the new one. So in that case, we also have option to provide ACL on both sides. So it's typically, I would recommend start doing with this one. Myro. So doing here, because then if we are ensuring that we are publishing messages in the format that is other subscriber can use, then we are ensuring that we won't break and we won't force others to immediately deploy the new version, because this downcasting needs to happen, of course, on the receiving side. So conceptually it's here. So we need to deploy new events to be able to do downcasting or upcasting. Okay, but if we don't want to do this caveman manipulations, then there is also other option to do to make it more generic. And let's say that we have a set of upcasting logic, because we have this initial version, then we have the version with the client, so the grouped client, and we also have the third version with the status. So we have 3 different versions of the shopping cart open. And we have a 3 different upcasting logic. One is upcasting version 1, and this is doing the manipulation just, for example, with the JSON, raw JSON. Then we have this additional upcasting for the version with the client, but without the status. And we could define a serializer that is capable of having multiple upcasting registered. So if we are trying to deserialize, then we don't need to provide a specific method how to handle parsing, but have it done automatically. So how to do it? So let's say that we have some event transformations. An event transformation would be a class that contain all the upcasters that we registered. So all potential upcasters that can happen in our system. And then if we have the deserialization logic, then we could try to transform, so upcast our event. So we are providing event type name and JSON. And if we manage to upcast, so there was define an upcasting logic for the following event type, then we are just returning this transformed value. So see a similar pattern like I show you in the TypeScript. And if I didn't have any transformation, then I'm just using the default transformation and call it a day, right? I have just event type mapping just to know how to map the string event type into the CLR, so the C# type. But this is a default deserialization. Let's have a look how event transformation looks like. So we have a dictionary of transformations. And this dictionary contains, the key is the event type name, and the other is the function that takes string, so JSON, and returns the specific upcasted object. And try transform works like, so the method that we saw here, so this one, try transform, try to search and find the potential upcasting. If there is no upcasting, then it just returns null and doesn't do anything. If it found the transformation, then it just runs the transformation and returns the result. Simple as that. And the registration of this transformation can be done in two ways. One is just taking the raw JSON, so event type name and transformation from the raw JSON into event. And we are just storing that. For this particular event type name, just transform it in this way. And we can also register that for the regular types. But in this case, we are first doing deserialization to the old event type and then using it in the transformation. So such registration can happen this way. So we have event transformation and we are registering that for event type name. So shopping cart initialized v1, use this upcasting logic. And for this type, once you have it, for this v2, then just do the CLR transformation and use this upcasting function. And then we can inject those transformation into our event serializer and just use such serializer, in the regular way. No need to inject anything more. So this is done. This is something that we could do in the application startup. This event transformation would be a singleton per our application lifetime. And we have all the transformations, and then we can just use the serialize. And such logic is pluggable into any potential way. So this can be plugged into this part or that part. So it doesn't needs to be made only for event sourcing, but it can be also made for like handling multiple versions coming from messaging system. So this is quite powerful technique. And let me show you, because in Marten, because what you see is also on my blog, but I decided to include that directly in Marten. So if you have, for example, if you'd like to upcast, let me just scroll to the upcasting logic. So see, you have a multiple ways. Options are our Marten configuration. And you can say that I would like to upcast the old event into the new one and just using the following transformation. There are multiple ways, like we can define a specific event type name. Marten is handling event type mapping automatically. Or we could even use this JSON serialization. So say like I'm using the JSON event and I'm doing this caveman deserialization. And in the same way, there are also multiple ways. You can also define class if you prefer to use class instead of injecting lambda. Then you can also derive from the event upcaster and do it the same way. So Marten, I know that Axon has also built-in capabilities for defining upcasters. Event Store DB doesn't have such, but I show you how it is really simple to do it. And to get back to the TypeScript code, in the same way, you can use the transformations. yes, this one. So you can define get shopping cart function and call C the same way. So I'm using precisely the same aggregate stream method, but for the parse method, I'm sending it from event parser, which is the class that is almost the same as I show you like here with the with our deserializer. Logically and conceptually, it's precisely the same part. So so in really those simple techniques, you can handle most of the scenarios that you have here. And really, I would say that if we are handling and ensuring and trying to model our event model evolution in a non-breaking manner, then that's really achievable, and those simple techniques should take you really, really far. So I want to also show you as the final grand finale, I would like to tell you what's the best way of handling versioning, and it's not what I show you. But before I move on to the grand finale, do you have any questions? Should I expand or describe those scenario a bit better, or maybe the other way around? Thank you, Vendrang. Happy that it's clear. So see, we can use also this upcasting here for read models. There is a question from Pavel. I saw that event sourcing systems where events were stored in separate topics by version. Is it good practice or not to store publish events in tables, queues by version? So if it's event sourcing one, then I would say that you typically, event store is a database. It's not a messaging system. So you store them as they are. Once you store the old version, then you should typically append to the same stream. So in that regard, you will need to keep all the events of the specific stream into in the same place. However, if you are publishing events to other systems, so here, then sometimes indeed people are publishing events like here is the topic with the old events and here is for the new one. So those advanced techniques I recommend to check Greg Young's book, Versioning Event Sourcing System. I'm not sure if if I can say if it's good or bad practice. I think that it can be useful to make explicit what you might expect and potentially maybe know whether you have some subscribers to the old topics with the old version. But if we are handling our events in the way that they are non-breaking, so they are both backward and forward compatible, then I would say that probably I would publish them in the same topic and in the same queue. However, it's a nice idea, and Greg is also explaining that stuff. But usually there is a challenge, because if you have those two topics, or some people are publishing two events, one in the old schema and one in the new one. But then for some specific time, quite often you need to subscribe to both topics, and then you need to understand and ensure that you are idempotent. So from which topic, which event you should use, and whether you already handle it or not. So I would say that this is non-trivial, but yeah, that's some potential way. I'm not sure, Pavel, if that answers your question, but if not, then feel free to follow up and I will try to be I try to explain it in a better way. So feel free to follow up. Okay, so I see that Martin wants to implement a few upcasters after that, and Vedran also. Yeah, nice. But let me show you some other possibility, because in my opinion, the best way of handling events versioning is to not need to handle it at all. I know that that sounds dumb, but that's real thing. So let's say that those are our events. So like those are our streams that we have in our system. And let's say that here, this is the perfect scenario where we don't have any new schema or old schema, just all using a single specific events. So let's make it a bit harder. So let's say that this is V2 and this is V3. So we have two streams that are having the old schema. So this one, let's use, like, let's make it pink to see it better. Which one? So those are with the old schema, and this is like a pinkish because it has, this is the latest schema, and those are with the old schema. And let's say that we are, because for such scenarios, we of course can use our upcasting logic. And once we are reading, so let's take this part. So once we are reading them, let's see if I can rotate it. Okay, the text will be upside down, but that doesn't matter much. So if we are reading it, then we can do the upcasting, right? So we can handle that with the upcasting. Maybe it's not a big deal for us to maintain multiple version, etc. So instead of that, we will get after upcasting only those events with the latest version. So that's simple. However, sometimes our stream definition changes significantly. Maybe it's not that simple as I show you. So maybe we are missing some data and maybe we would like to have them, or maybe it's so annoying for us that we need to always keep that in mind, because remember, this is not the only place that we need to handle those versions, because we need to handle them also in read models. We need read models in projections. We also need to do the upcasting. Of course, we can plug the generic mechanism as I show you, and that's not getting super hard. But how to get rid of those old versions, especially this is really important for scenarios for integration. So let's say that those events were actually appended in a different way, because let's have a look on how they look in the real event store or even in messaging system. So this could be like this for sure was appended as the last one, because this is the latest event. Then this was maybe appended here, and this may be here. So those are our streams. Of course, probably they mixed a bit in the order, but let's keep it simple. So this will be our global log. And if we are using Kafka, then you can think that those events could potentially be a partition in Kafka and topic, whatever, the same stuff. So what we can notice here is that if we put a time on this one, so this is how the lifetime of our project look like. Those are the oldest, and those are the newest one. And we see that here we introduced the v3, the latest version, right? All that happened before may contain the old versions. And let's say that we would like to, once we deployed this v3, then we want to keep it compatible with the v1 and with the v2 and v1. So this shopping cart event will contain union of all properties from v1, v2, v3. So this can be annoying because as I show you here, then if we have the union of all possible types, then our payload has some potential redundant data. So this will be looking more or less like that. So we see this client ID is the same one as here. And if we have more changes to our schema, then we will have more and more duplication, right? And this duplication at some point, together with the upcasting, if we need to constantly do upcasting, then of course that decreases our performance. And if we are adding this duplication, more and more duplication like that, then our events are becoming bigger and bigger. So how to deal with that? So this is like how our payload looks like. And this is potentially a duplication because we want to be compatible. And now let's say that we would like to get rid of them. And how long can shopping cart live? Like, what, in your opinion, what's the typical lifetime of the shopping cart? I would say that typical shopping cart just lives a few hours or maybe day. But let's say that we have the, let's say that we want to be on the safe side, and we would like to get rid of those potential old data, so this client ID, once in about 2 weeks from now. Because this is our sprint, it will look nice in Jira, etc. So we would like to get rid of all the schema versions at that time. So potentially at that time, probably this will be shopping cart confirmed for this shopping cart. This one is already confirmed, and this will be confirmed for this one, right? So this is how our events will be looking like. Because in the meantime, the lifetime of our application will continue. And definitely within those 2 weeks, those shopping carts with the old, potentially old schema will be just either confirmed or cancelled. And the new events we will have in the schema that is both forward and backward compatible. And maybe if we assume that there are no records that could be used to have those old event types, then maybe we can just ignore those old payloads and from now on just proceed with the only v3. Because technically we won't be doing any operations on those particular streams, because you cannot do any business operation on already confirmed shopping carts. So effectively there won't be any living shopping carts that will contain the old events with the old schema. And then for those events, technically we can define some strategy around the archival. So we can potentially archive them, even move from our event store, because we won't need them for the specific logic. Of course, there is a then question about the projection rebuilds, because we won't need those old events from this part, so for the business logic, but we might need them for the read models. And for the read models, because we would like to maybe be able to rebuild the read models, build new one or on old data, then that's quite often the case where we keep because why we keep those old events. And maybe in that case, we can, for example, append just a summary. So a new version like a shopping cart. This is a really dumb name. Don't do that on, on production. But maybe for those events with the old one, maybe we can just provide a summary event that would just have all the information from the past data and introduce that event and use that event for projection rebuilds or for publishing, etc. So if we care about the archiving our old events and old schemas, then if we are doing that on the constant basis, then this can help us and make us not needing to maintain all of our past event scenarios. And the same goes for integration with other systems. Of course, it's a bit tricky because typically those two modules will be handled by different teams, different deployments. So usually we need to do a bit more time. But if we want, then we can plan and discuss with the other team and say like, hey, publishing those events that are forward and backward compatible is a big effort for me. Then let's agree that I will be doing that for the next month or two. But you need to handle the new version of our schema, the latest one. And if you don't, then after those 2 months, we will stop producing events with the old schema, and they won't be anymore backward compatible. So in that regards, even if we are making the breaking change, then we can proceed with that in a non-breaking manner. And the other really, really important part is located here. So if we were publishing all those granular events to messaging system, and this shopping cart will need to subscribe to all of those tiny events, then each time we are doing breaking change, we are doomed, because each potentially breaking change to the schema can affect the other modules. And this part, so doing the ACL on the publisher side, is really important, and having the clear split of the private and public events. Because if we have such transformation that once we got the shopping cart confirmed, let me just move it a bit more down. So let's say that we have the shopping cart module, and we have the shipment module. and let's say that we have like V1, V2, someone was really lagging, or we were introducing those changes really fast. Then let's say that we have those events, and all of those events, if they were if the shipment module will subscribe to that, then they will need to handle all the potential versioning that we have. However, typically that's not the case, because typically shipment module will care only about the confirmed shopping carts. So if we place here the transformation, and we will subscribe only to the shopping cart confirmed, and we will transform it into the other representation. So let's mark it as external, because just to show you that this is different event. Then if we do this transformation, and if we publish that to only this transformed event to the shipments, then if they are only subscribing to this event through the messaging system, then on this part we can do much more easily all the other transformation that we have. Because then if we have such thing, then why not? We can introduce the version 3. And as we discussed, inside the single module and the single deployment, it's much easier to handle next versions of the specific thing. So here we would just subscribe to the final event, and then we are typically either loading all the events and building representation or querying read model, whatever we do to enrich and provide the final version, like the external events to the outside world, then we can do here in this particular place all the ACL logic that we want to, and even potentially the shipment module doesn't need to do anything, because if we introduced here and we massaged this breaking changes, potentially breaking changes with upcasting, with other strategies that we discuss, then here, if we are having this additional stuff, then here we are doing upcasting, downcasting, whatever we want. But here we are ensuring that the contract and the data that we are pushing outside is compatible to all subscribers. And by the simple techniques, and as I said, hygiene, and a proper engineering approach, we don't need to really do any sophisticated topic management, etc. Of course, there might be scenarios where we need to do some bigger migration. Then we might do some stuff like copy and transform. So take this whole stream, transform it into different representation, and publish it outside. But usually, from my experience, if we care about other people's work, if we put thinking about the modeling and versioning and how to tackle that into the design process, then we really, with those techniques that I mentioned, you can handle really most of the stuff. And some people are asking me like, okay, then I have 7 versions of the specific events. And that's annoying and I cannot handle that anymore. And in that case, to me, that's unfortunately a sign that we should get back to the drawing board, because that really rarely business process is changing so often. What changes quite often is our understanding of this particular business process. So if we have such a big amount of the different version, then that means that unfortunately we are not doing a great job on talking with business. And maybe we should stop, do sanity check, and talk more with our business and try to understand why we have such a big amount of changes that we need to provide those different versions and that we cannot handle with those simple mappings that I mentioned. Because of course, it might happen that we have new field, new data, that's obvious. But as we discussed, new field usually is not a big deal. We can handle that even on the serializer level, accepting that for the old events, we might not have this information. But usually, I would say that that's an indicator that we are not doing a great job on modeling, unfortunately. And I'm also telling that about myself because I did that in past. There is comment from Martin. So there are domains where government's laws come out rather frequent and you have to change your design. Yes, sometimes that happens, and especially regulations that are coming from the next year and are announced in December, and you need to write in a rush. So I'm not saying that this is always the case, but from my experience, usually the case. And if the process is changing so significantly, then you can do the mentioned by me copy and transform. And copy and transform works in a way that you take one set of one stream, and usually the copy and transform you need to do when you cannot just map event one-to-one, because maybe you had an issue that you'd like to, for example, product item added to shopping cart, and you had multiple events like that, and now you would like to union that into some other. Then you can take this set of events and also transform them and usually it's done like that. So you take those events from event store, you read them, and you do the transformation. And once you got the new shopping, the newly transformed stream, then you are appending that into some, again, into either the same stream or usually the different one. So maybe that can be like previously you had 5 events and now you would like to have 3 and maybe some other, or maybe you need to enrich those events and read some additional data from some read model. So that may be also the case. But then you can do it this way. But to be true, I wasn't doing that type of logic too much, but sometimes it happens, and that's a valid scenario. So it's like I even have example of that, but that's really, I would say, showing that in the end can be too mind-blowing. But we can add additional layer to our deserializer. So provide to deserialize the whole list of the stream. Then we might have the stream transformation. So we are taking all events and in the same way checking if we can transform them. So this works this way. So we are checking if we have some stream transformation. If we don't, then we return events as they are. But if we have, then we can run some transformation for the whole stream. And this transformation can be also a function that takes events and returns different set of events. So we can do it also the same way and use also the same technique also for this copy and transform. So as I said, based on what we discussed, you can build and you can provide even more fancy way of handling such stuff. Okay, so I will be trying to wrap it up. If you have any question, then feel free to ask them in the meantime. So we discussed today multiple options how to handle our schema versioning and schema migration. So the most obvious way is this ugly one rule. The only rule that I really suggest you to follow: do not do breaking changes. I'm really usually like, well, it depends, but in that case, I really suggest do not do breaking changes for schema. And if we are not doing breaking changes, if we have our contracts and events are our contracts in both forward and backward compatible, then handling them becomes much, much easier. And backward compatibility is glossed and explained much more ways and much more often. However, forward compatibility is also important because nowadays we can easily have systems that are capable of handling old schema, new schema at the same time, even the same instances of our service. So if we are introducing our schema that can be handled both by old subscriber and new subscribers, then we are just making our life much, much easier. Of course, it's like Aaron Stannard said in his optionality talk, it's about giving ourselves more option. Giving ourselves more option requires a bit more work upfront. I wouldn't say that it's extremely a lot work upfront, but we need, of course, to think and understand that our schema is changing, then understand why is it changing, and then choose which technique we will use for this particular case. And of course, doing migrations is in general easier if it's handling inside our module, inside the boundary, so inside bounded context and a single team. But sometimes that might also mean that this actually are more than a single service. And we also need to take into consideration some more advanced techniques. But the stuff that we discussed, so handling simple mappings through serializer, transformation, so upcasting to the new schema from old one and downcasting from new to the schema that is compatible with all previous schemas, is really essential, and it's really simple. Logically, it's just a basic transformation and mapping from either old object or just old payload into the new event type. And that can be also handled not only in event sourcing, but in general also for messaging, handling events coming or comments coming from messaging systems like Kafka, Rabbit, etc. But in general, the most important part is here. So the magic trick to handle versioning is to not need to handle this versioning. So in messaging systems, it is a bit easier because they have their retention policy, and the events will, old schema will just disappear. In event sourcing is a bit harder because we are storing those events durable. But if we have this archive techniques and if we know this lifetime of our objects, then we can have just this period that we will need to support both versions. But after that, we might just have the new version, because all the records and all the streams that have old events in the old schema will effectively be already closed, and we won't have those streams accessed anyhow. We can do some summary event and do the mapping and just store the summary if we want to do the rebuilds. So I'm not saying that it is easy. Simple is not always easy. But once we know and practice those simple techniques, then as you see, they are really, really composable and quite powerful. And I think that the versioning in general shouldn't be that scary if we accept that the change will come, because it will. So that's all from me. I hope that this will be helpful for you. The Miro board I will send you also later on, read-only access and some other reference materials. But if you have any more questions, then feel free to ask them now. Again, I'm not great on planning. It was again supposed to be 1 hour and a half, but it's a bit longer. So thank you for staying with me. And if you have any questions, I can answer them. Thanks, Zach. Glad that you like it. Thanks, Vedran. Thanks, Martin. And thanks, Pavel and Daniel and Manuel for staying also with me. Okay, so cool. Thank you again. If something pops out after you rethink what we did, and or once you want again the recording, then feel free to ask on Discord. I will try to cover all of that. But yeah, for now, I would say that, again, thanks for staying with me, and have a great afternoon. Manuel, have a great rest of the day. It's earlier for you. And thank you, Pavel, for the kind words. Yeah. Okay, guys. So thanks. Bye.